Thanks, Clark, for the intro, and thanks everyone for having me. I'm excited to be here and talking to you about particle and the Internet of Things and hardware and startups, because the story I'm going to tell you today is kind of our origin story, is like how did we get to be what we are today and what are the trials and tribulations we went through. And some of it is specific to us because we make physical hardware, and other parts of it are just kind of the startup journey. But I want to share that experience with you today. And first, I'll take Clark's. Here are the wonderful sponsors that have supported this event. So thanks to all of them. Yeah, all right. So this story is called From Zero to One to 100,000. And it's the story of us going from nothing, an idea, to having a product, launching it on Kickstarter, and then scaling that product and that business. So just to introduce myself, I'm Zach Supalla. I'm the CEO of Particle. You might know us as Spark, which was our name up until last summer. And I'm also at ZS on Twitter, so feel free to, tweet about some things. So before I talk about Particle, I want to talk about the Internet of Things. And let's start with what is the Internet of Things. It's a really overhyped term. It's a new industry that is sort of poorly defined. So I love to do Google image searches to define things. So this is what, if you do a Google image search of Internet of Things, this is what you see, which is a lot of graphics of objects connected with lines, usually in nonsensical ways. So like, I don't know why my plane needs to talk to my toaster, but they do in these kinds of graphics. So I like to say that this is the Venn diagram of people who create IoT graphics and people who understand the Internet of Things. These graphics, yeah. For any of you who are I mean, we're all technical here, so I'm sure everyone looks at this stuff and is like, oh my God, that's exactly what they do with, what I do too. So, okay, it's a very poorly understood area, and it's also that way because there's a lot of sort of crappy products. Here's a crappy product. This is a connected basketball. It will track. It costs $199. You can buy it at various retailers. It will track how many baskets you shoot. No offense to Wilson, I think this is a little silly because A, it's $200, and B, it's got a Bluetooth chip on one of the sides, and if you dribble it on that spot, it just goes thunk, and it hits the ground and won't bounce. So there's a lot of poor IoT products out there, but I don't want our experience of IoT to be driven by those, just like your experience of gaming should not be driven by this. Who knows what this is? E.T. Why is it famous? Because it sucks. Yeah, it's the worst video game, lowest rated video game in history, I believe. So, okay, Internet of Things is not connected basketballs, just like gaming is not E.T., right? What the Internet of Things is in a lot of ways, there's sort of three paradigms for how these types of devices work. One is you have data that you use to drive actuators. Actuators are the opposite of sensors. They're something that controls the physical world, like a motor or a pump or a light or something like that. A great example of this is a customer of ours called Opti. They do stormwater management. So basically, weather's becoming more extreme. It's starting to, there's a lot of flooding in various parts of the world. Some of that is because the stormwater systems aren't able to manage the drainage of a really intense storm. And so what they do is they connect to the stormwater system. Let's say it's going to rain 5 inches tomorrow in an hour. That would usually be a flash flood. But what they can do is empty out the reservoir 5 inches today, so instead of the reservoir overflowing when that 5 inches of rain happens, it just fills back up. And so that's an example of using data to drive a very simple actuator. It's just a water pump at the end of the day. The second is sensors driving insight, right? Collecting information about the world. And so you might think of this, it's kind of the opposite, right? So you might have a product that is collecting data about temperature and humidity and light on a vineyard, right? You have a vineyard is a hilly area. You might be trying to plant, figure out where you want to plant certain kinds of grapes. It's a high-value asset, so you want to do it well. So, okay, if you had a sensor network all around the vineyard, then you could collect information and figure out what grapes will grow well in various places. And that's using sensors to drive insight. And then you have the cool stuff, which is where you do a little bit of both. And the best example of this is the Nest thermostat, where a thermostat is both a sensor and an actuator, right? It senses the temperature in your house. It also controls your heating and air conditioning systems. And so it can collect information about how hot it is in your house and use that to drive an actuator, which is just how every thermostat works. But when you bring it all into the web and you collect that information, now you can start to do machine learning. You can do intelligent things that you couldn't do before and actually improve the quality of everybody, decrease our energy costs, increase our comfort at home, and that happens through collecting data in a central place. And I believe that the Internet of Things is the third wave of computing. What I mean by that is the first wave was the PC, the second wave was the smartphone, and the third wave is the Internet of Things. And in a lot of ways, this kind of echoes the second wave. Smartphones were enabled by technology that was built for laptops, right? And that technology started to get small and cheap enough that you could do powerful phones. And similarly, now we've built such small, cheap technology for phones that we can start to use it in the next tier of devices, the really low-cost, tiny, cheap, battery-powered stuff. But at the same time, we're not really there yet. I think we're in the Commodore 64 days of the Internet of Things. And by that I mean a couple things. Who had a Commodore 64? Yeah, all right. So Commodore 64 days, one, we're sort of standard operating system that works on all hardware. So software has to be written for different ecosystems separately, right? That was a challenge for software developers that eventually got solved with OSs. That's where we are in Internet of Things, is there isn't kind of the standard ecosystem for writing software yet. But second, it's also, the space is also kind of being owned by hackers right now. Just like in the Commodore 64 days, where the people who were driving the experience were all people who were figuring out how to make stuff, and code stuff. That's what's happening now in the space. A lot of the Internet of Things is being explored by makers. And we're going to talk about that a little bit today. And so this is the world that we Spark then Particle came into, right? So this is from my pitch deck in my first pitch deck in 2012, which said that today's smart home is like a computer without an operating system. That basically there are these companies, the Samsungs and Honeywells of the world, that want to create these cool products, but there's no way for us to build applications to interact with those products because there isn't yet an OS. And that drives a lot of our story. So now we get into, we'll start with Spark. And actually, before it was called Spark, it was called Switch for 20 minutes, and nobody ever knew that. So we'll start with zero, right? Here's us getting off the ground. And in January 2012, I filmed the creation of my first Arduino prototype where I blinked an LED. So let's start with that.
Hey guys, just showing you what I was up to today. We got a little LED light here connected to the Arduino. We got something up on the computer screen and something on the phone. Oh, that's my dog. So, fancy. If we go up here and click on this little button right there, oh, light turns on. Oh, and light turns off.
But you can't see it, it's up.
And on and off. So that's pretty cool. But really it's just connected to the computer. The cool part is that we got it hooked up to the internet as well. So if I click this little button on my phone, we're turning a light on and off. Pretty cool. Hope you guys enjoyed.
So if you've ever done, actually, let me ask this. How many people have played with hardware? Raise your hand. All right, cool. A pretty decent amount. So if you did, this is probably where you started, right? Is flashing a little LED, and that, that's the hello world of hardware. So that was my first experience in January 2012. And I'm not an engineer by background. After this, I learned a lot. I became a self-taught electrical engineer and front-end engineer because that's what you do when you're doing a startup. But the idea that I was starting with, I called this home lighting kit. And the lighting kit, the inspiration for this is that my dad is deaf. And I really wanted to connect his lights to the internet so I could make his lights flash when my mom sent him a text message. So the deaf have had hardwired lighting systems for decades now. But they work with teletypes that plug into a phone jack. And so I wanted to do something that was wireless so he could use it, so it would work when he was using his smartphone. So I just needed his lights to be online and API accessible. And then I could do a Twilio integration or something like that. But that wasn't a thing. So I wanted to build a product that would give your lights an API. And my thought was, if this existed, then people could create a lot of different applications for lights. So it's not just about remote control, like moving the light switch from the wall to your pocket. It's about, notifications for the deaf. It's about immersive gaming, like your lights flicker in your living room when you're playing a video game to sort of create more ambiance, right? It's different applications like that. And so, my first prototypes started out looking like this kind of mess of wires. This is an Arduino Pro Micro hooked up to a Zigbee breakout board. You can see this is sort of plugged into a light socket. This is terribly dangerous. Don't do this. This is our next prototype, which I refer to as the pipe bomb. It's screwed into a light bulb socket on one end, and then the light bulb screwed in the other end. And in the center are like a stack of circular PCBs, circuit boards, that make this thing work and basically provide a dimmer switch and a Wi-Fi connection. And so you can now control this light online. And by the way, I didn't have an electrical engineering degree, and you should be really careful with voltages, with plugging into the mains when you don't know what you're doing. We'll talk about me going to China later, but I discovered that 50 hertz feels different than 60 hertz. It's a little slower. You can feel it. And so, okay, great, we have this pipe bomb. Now I need to make it look like something somebody will want to buy. And so we hired a industrial designer. At some point, we rebranded to Spark along the way. And we hired an industrial designer to create a handful of designs. This is one of them, which he called Pinch. And it was sort of inspired by the jawbone up, geometric shapes. And we liked it. It looked cool, and that was a glowing LED in front. And so I wanted to show this off in a Kickstarter campaign. So we 3D printed these using a technology called SLA, paid a couple $100 for some SLA prototypes. I bought some high-end spray paint, and this is in the Mill, which was a makerspace in Minneapolis that's unfortunately defunct. And the result was this, which actually looks really nice, even though it's spray-painted SLA. Good lighting does a lot. And so this was enough. We had a functional prototype. We had looks like a cosmetic prototype. And that was enough for us to do a Kickstarter campaign. And here is the video for the Kickstarter campaign for the Spark socket. Hi, I'm Zach. And this is Spark.
Spark is a simple product that connects your lights to the internet so they can be controlled from any smartphone, tablet, or computer. Plug the Spark socket into any standard light fixture, screw a dimmable bulb in the other end, and set the system up over Wi-Fi. In just a few minutes, you've got full, dimmable, smart control of your lights from anywhere in the world. Spark was inspired by my dad, who's deaf, and uses lights for notifications. When I was a kid, the lights would flash if somebody was at the door or if the phone was ringing. But now that my dad uses a cell phone, the system doesn't work, and everything falls apart if his phone's not in his pocket. learned something from my dad. To me, lights were just lights. You turn them on when you need to see, and you turn them off when you're going to bed. But to the deaf community, there's so much more. Lights are a source of information. They tell you something about the world. We use lights like this in very limited ways. You've got the status lights on your car dashboard, or the indicator lights on your computer or electronics. But what if we could do this in our homes? What if lights were more than just lights? Enter Spark. First, Spark gives you complete control of your lights from an iPhone, Android phone, or any web-enabled device. You get full dimming control, great for mood lighting when you're eating dinner or watching a movie. But Spark is so much more than just remote control. For instance, you can use Spark as an alarm clock, slowly turning on the lights to help you wake up naturally. You can program your lights to dim during the day, to use less power, or turn on and off while you're on vacation to make it look like someone's home. And as for notifications, as my dad requested, Spark can let you know when you've got a new text message or an email by flashing your lights. There are a million other things that we think could be built with Spark, but we need your help. The power of Spark comes from our developer-friendly API, and we can't wait to see what apps people can build for your lights.
There were all sorts of things about that video that were faked. Actually, almost everything. All the dimming scenes, we just were sitting there with a dimmer switch. If you notice when the guy was coding, that was just a screenshot of like someone coding. There was no typing actually happening. But you know, that's the magic of video, right? We did have a functional prototype, so we knew we could pull it off. We had one that actually was in this form factor, and I blew the circuit like 3 days before we had to film, because I connected the high voltage and the low voltage sides by accident with a soldering iron. Just blew the whole thing. So we faked the video. But it didn't matter because nobody bought it. Or rather, not enough people bought it. So this is the end result of this Kickstarter campaign. We were looking for $250,000, which seems like a lot, and it is. But this is an expensive to manufacture product. It has UL certification, it has safety certification, it's got a lot of plastic, and that has tooling costs. And we didn't have any money, so we needed to get all of the funding for this product from Kickstarter. $250,000 was the right amount, and we only raised $125,000, which in a lot of people's eyes would be a successful Kickstarter campaign. But for us, it wasn't, because we wouldn't have had enough money to make the product. And I got a lot of advice to take our goal down, to set a lower goal so that we could be successful, and then we'd just figure it out later, right? And I was really hesitant to do that, and I'm glad that I didn't, because it wasn't successful enough. And the fact that this didn't hit its goal released us from the obligation of actually creating the product and gave us the opportunity instead to kind of rethink our business and figure out what we wanted to do next. So with that, I go into the next section of my presentation, still zero. We still haven't gotten to one yet. And instead, we're kind of starting over from scratch. So at this point, it wasn't just me anymore. I had a co-founder, our first couple employees, and we flew to China. We did a program called Hexcelerator, now called HAX, which is based in Shenzhen. And this is for hardware startups, American, European, and some Asian hardware startups that come together in Shenzhen to learn how to prototype, how to manufacture products, and how to get a hardware business off the ground. And while we were there, we didn't really know what we were yet. We thought we still wanted to create this lighting experience, but we wanted to do it in a way that was cheaper. How do we get that $250,000 goal down? Well, if it didn't require any certifications and it didn't have any plastic, then we could make them at smaller quantities and without all that fixed cost. And so we designed something called the limited run. And this was a connected lamp that would, with a CNC milled wood base and acrylic sheets as a lampshade, that would be the same experience, but without any fixed costs. It was a very limited run. We never made any. This is a rendering. And it's the furthest that this project ever got. Because we started to realize, like, okay, what path are we on now? Like, we're becoming a lamp company. And if you're a lamp company, you're a design company. And you have to make a lamp for every person, because every person has a different place they want to put it and has different aesthetic tastes. and we didn't really want to be in that business. So we thought, well, we're in China. There's a lot of companies that make lamps and lighting products. Why don't we just find somebody that makes something that we can just like drop a chip in, right? And like add technology to an existing product rather than building one from scratch. And we found on Taobao, who knows what Taobao is? Taobao is awesome. Taobao is like the Chinese eBay. And it's like if eBay existed in a world where Amazon never happened and eBay just took over the world, that's Taobao, and it's awesome. So we found on Taobao these companies that were creating these balls, these lit up LED balls, and these are pool furniture, actually, or like pool decoration. That thing is waterproof, IP67 waterproof. You can throw it out into water. It's inductively charged. It costs like $25. And it has a little LED in there, and it's got an infrared controller. It's full color. And you have this IR controller that lets you like pick the color of these things. So we thought, well, what if we just replaced the IR controller with like a little Wi-Fi controller? And that way we'd have our connected light, but we wouldn't have to build something from scratch. And we came back to the board that was in the socket. So this was, in the socket design, there was a high voltage board and there was a separate low voltage board. And the low voltage board had the microcontroller and the Wi-Fi module on it. And we looked at it and said, you know, if we just redesign this so that we could stick it inside this, this ball, then we could connect that ball to the internet with a small amount of work. And so we turned it into, we changed the form factor so it was like a pluggable design. And we called this the Spark Core. It was the core because it was the core of the socket. It was the center of this other product that we pulled out. And once we created this, we realized that we had something. That actually there was no reason to limit this product or this technology to just lighting. We could instead go for a platform strategy. What if we took the technology that we built for our own product and we released it as a platform for other companies to use to build their products? So instead of launching the Spark Orb, which is another product that never came to be, although we do have 10 of them, they exist somewhere in the world, we decided to relaunch on Kickstarter 6 months later with the Spark Core.
This is the internet. Well, maybe not the internet you're used to. This little guy connects to the internet over Wi-Fi. And when he does, he brings along whatever he's connected to. Power outlets, buttons, cameras, remote control cars. And when the internet spills over into the real world, exciting things happen, like toys that learn, or lights that know when you're home, or Wi-Fi PB&J. With the simplicity of an Arduino and the power of an ARM chip, this is the Spark Core. I'm Zach from the Spark team, and we're in China. We came here to join Accelerator, the premier incubator for hardware startups. Accelerator is based in Shenzhen, the electronics capital of the world, and a great place to build something new. We've spent the last year creating Wi-Fi connected products. A lot of people are building connected things, but we all struggle with the same problem. Adding Wi-Fi to a product is either very difficult, very expensive, or both.
So we built the Spark Core. This little board solves all the problems with making Wi-Fi connected products. The setup is seamless and everything is secure. It runs the Arduino code you're used to, and you can program it wirelessly. This means it's a lot easier to add Wi-Fi now, so we hope you'll build it into your own projects, and maybe even find it in some products off the shelf.
Gosh, it's crowded in here. With the help of our friends at Accelerator, we've already started making cool projects with the Spark Core. Here are a few of our favorites.
First, there's a robot you can control with your phone. Nice driving, Kenny. Or this awesome pizza orderer. Just flip the switch to arm the button and press it to irreversibly order a hot, delicious pie right to your door.
Well, it's gonna take 45 minutes.
And finally, an LCD fridge magnet that displays your favorite Twitter feed. The possibilities are basically infinite.
We
heading home to the States, but the real journey begins here. Back our campaign to get your own Spark Core and come along for the ride. And then the only question is, what will you build first?
So this time things turned out differently. We had a $10,000 goal, and it was low because this was a very easy product to manufacture. No fixed costs, no tooling, no certifications. $10,000 goal, we raised almost $600,000. So this worked, and we seemed to have scratched an itch. It seemed like there was actually something here. And if for anyone who was playing around with this stuff in mid-2013 when we launched this product, the alternatives at that time are really, really poor. The best you could do was like $120 on an Arduino plus a Wi-Fi shield, and it was big and it was really hard to use. And so there was a big opportunity for us to create a development experience around this. But this is what got us from 0 to 1. And the first lesson, startup lesson out of this is resilience. It would have been very easy for us to stop at any point in that process and just say like, okay, we're going to close up shop. And instead, we kept going and we kept searching for the opportunity for us, and that led us to the path that we're on now, which was to become a platform company. Now, the next thing we had to do was manufacture this product. Manufacturing is hard, and hardware is hard. And so I want to show you a little bit about how the factory works. So this is kind of a Mr. Rogers tour of a Shenzhen PCBA circuit board assembly process. Now, if you haven't spent much time in a factory, this is probably what a factory looks like to you, or what you imagine a factory looking like. This is Tesla. This is how Teslas are assembled. It's all robotics. It's super clean and very fancy and highly automated. This is what our manufacturing facility looks like. It's not quite the same. It's much smaller. There are a handful of people that work. It is actually quite automated, but it's more like a pizza oven than it is like the car assembly that you saw there. This is our manufacturing team. This is a combination of people who work directly for Particle and people who work for our contract manufacturer, a company called AQS, that we've been working with for years now. I'm going to talk through the process of how one of these boards gets assembled. So the first thing that happens is you have just kind of the raw circuit board, and you can see that these are like rows and rows and rows of just PCBs that are all panelized. So they're put together, a bunch of them on one like square, so that they can be sent through a manufacturing line. The next thing is that you put on solder paste. So basically, this is the glue that holds down the components and provides electrical connectivity. And it's a lot like solder, but it comes in a liquid form so that it can be basically squeegeed through this screen onto the pads that are on the board. The next thing is that the components are placed. This is called a pick-and-place machine. So this is the part that's most like Tesla. That machine very, very quickly drops all the little components on the board. When we do small volume production, we have a guy with a pair of tweezers. So this is like a really, really fast dude with a pair of tweezers. The next thing is you reflow the components, which is basically melting that solder paste so that it reforms and creates a connection, both electrical and mechanical, between the components and the board. And it looks like a giant pizza oven, and basically is, except it's a lot more refined. The next thing is you solder on the pins. So like along the sides, there's actually connections that can't be done with, that aren't just surface mount, they're through hole. And so you use this technique called wave soldering, where you can see there's like a bubbly fountain of solder that's really, really hot, and then you just skim the board over the fountain, and it solders down the bottom. Then there's inspection. And so you have a machine that will inspect all the components to make sure that they're not turned sideways or upside down or something, which they are. And you're like, how did that get upside down? A robot put it on. I don't know why it's like that. How did that happen? It happens sometimes. Then you have functional testing. So we built these testing boxes ourselves. And I just want to show you like how much of a kind of a little bit of a mess it is in these processes. Like, look at that guy just like drop one. Like, oh, he picks it back up again. Like that's, that's what the process is. The biggest challenge we had, or one of the biggest challenges we had with manufacturing is that the people who were doing the test took about 2 minutes, and it was long enough for somebody to get bored, so they would pull out their phone and they'd start playing a game, and then they wouldn't realize that the test was done, and so our average testing time was like 4 minutes, because 2 minutes the dude's just playing this game. And so we had to like shorten the time down to short enough time when they wouldn't get bored, and then all of a sudden like that went away. Another just interesting anecdote about Chinese manufacturing versus American manufacturing. So in the US, you can't use red and green as distinguishing characteristics for pass and fail because the person on the machine might be colorblind, right? And so you can't be 100% confident that that person can do that test. In China, they don't have labor laws the same as ours, so they just don't hire people who are colorblind. And so you can do a red-green test and know that the person running the test isn't colorblind because they screen for that in China. It's like, this is weird stuff that you learn when you do international manufacturing. And then someone does rework of failures. So anytime one of these boards doesn't work, somebody goes in and fixes it. And that happens a very small fraction of the time. Then finally, you package this. This product. And so this is the Photon on the left and one of our maker kits on the right, some of our development products. Okay, we have now assembled this product. Now, setting up this manufacturing supply chain took about 6-9 months the first time around, and then every time it's a little bit faster now that we actually kind of know what we're doing. But if you go back in time, our Kickstarter campaign was May 2013, and we shipped the product to the first time in November of 2013. And here's a video from the first conference, RobotsConf, where we shipped this product and actually had people using it in real life.
It's all right. We know it's there.
All right.
All right, so what do you got going on here?
So we have a SumoBot
Yep.
with a Spark core,
Yep.
and we're going to plug a battery into this guy. So it goes. It's going to connect to the Wi-Fi. You can see the core inside there.
Nice. RobotsConf logo on the top.
And here we go.
Nice. So you're controlling this from your computer?
I'm controlling this wirelessly from my computer.
Awesome. And you're doing that with your own Spark library, right?
Yeah, I'm doing that with Sparky, Node.js Spark Core library.
Awesome.
Open source.
Very cool. So you're about to compete in the SumoBot competition?
Yep.
All right. And how do you think you're going to do?
I think I am going to win as long as the server stays up. And
Nice.
the network works.
Right. Sweet. Well, we're rooting for you.
Thanks.
That SumoBot lost in the SumoBot competition. And the reason it lost was because the SumoBot fighting area was on the edge of the Wi-Fi network range. And so what would happen is they'd go forward, and then like halfway across the arena, it would lose Wi-Fi signal, and they wouldn't be able to control it anymore, and it would just keep driving right out of the other side. And they were like, "Oh, screw you, Spark!" And we're like, "No, it was the what? Oh God, oh well." Physical products, huh? So I want to share a couple quick horror stories about manufacturing to explain some of the things that happen when you manufacture a product. The first run of Spark cores are white. And if anybody's used with a Spark core or a Photon or an Electron or one of our development boards, you'll know that they're now black. Well, it turns out manufacturing white products is very, very difficult. They don't stay white. So if you look carefully, and you can't really see it on this screen, this circuit board is just a little bit pink. And the reason it's pink is because underneath the solder mask, there's a layer of epoxy. And that epoxy is red. If you have a dark color solder mask, you don't ever see the red, so you don't even know it's red. Or it's red when it cures. So when you have a white board and you have to heat it in the oven, the red starts to come through. So one day I get a panicked call from Will, who's in China, and he says, "Zach, the boards are turning pink." And I said, "How pink? Are we talking like pink pink, or are we talking like sunburnt pink?" And he's like, "Some of them are one way, some of them are the other way. I don't really know." And so we had like a week where we had to figure out a QA process, an acceptable amount of pink that we would ship to customers. If it were too pink, we wouldn't ship it because we thought it would look a little weird. It was on a white breadboard, and it would be very obviously pink. So we set an acceptable amount of pink, and then we stopped manufacturing white PCBs. If you ask, who knows Little Bits? A couple people. Little Bits uses white circuit boards, and they've fired like 4 different manufacturers because they can't stay white enough. So it's like these are the problems you run into when you make hardware. Another problem that we ran into recently is the earthquake in Taiwan in February. So February this year, there was a big earthquake in Taiwan. Buildings came down like this. And we learned a couple months ago that the supply chain for our Wi-Fi chips had been disrupted. And that there was going to be like 4 months where nobody could get these Wi-Fi chips. It's a Broadcom BCM43362. They've been out for months. And we're struggling to figure out how to get product to our customers who need it to do their work. But we're running out. And eventually the supply chain will get rebooted, but for a while we just have to deal with it because we make hardware. So the second lesson we learned is that hardware is hard, which is a commonly used adage in this space. And that sounds like, okay, well, it just sucks, like you shouldn't do hardware. But actually, it's turned out to be a huge benefit to us as a company because it was really hard the first time, and now we've gotten pretty good at it. Our manufacturing yield is 99.7%. We're good at this stuff now, and other companies aren't. So what happens is other companies rip off our product and try and do the same thing, and they can't because they screw up on the manufacturing, and that means that we continue to be successful. It's created a moat around our business, which we're very grateful for. Okay, we've now shipped our first 10,000, and let's talk about how we got to 100,000. So, because this is more about the business than about the idea or the manufacturing. And I want to talk about makers. Raise your hand if you would consider yourself a maker. Okay, so there's a decent number of folks. So we had this question: who are makers? Who are these people who are buying our products, and why? What are they using it for? Well, most of what we think of as makers is driven by Make Media and Maker Media and Make Magazine and Maker Faire. And so this is an ad for Maker Faire, and so you can see a lot of what we think makers are embedded in this graphic, right? Robotics and rockets and arts and kids, DIY, right? It's sort of this like hobbyist, all this cool fun stuff. But you can summarize this by saying makers are people who build things, which is of course a little bit of a tautology, like makers make stuff. Yeah, okay, great. Well, what else defines this group of people? Well, they tend to use a set of tools that are things like this, right? Arduino, Raspberry Pi, SparkFun, Adafruit, Little Bits, Seed Studio. These are all maker tools that you can use to make stuff. So, okay, makers are people who use tools to build things. But why are they building things? Well, a lot of times they're building stuff for fun. So this is from Maker Faire. I don't actually know what these are, but they look awesome. Sort of bicycle-y things. If you've been to a Maker Faire, you'll see tons of stuff like this. It's I had a friend who described Maker Faire as Burning Man with pants, which is sort of accurate. It's like all sorts of cool, fun, interactive art and like just really like crazy stuff that people have built. Okay, so makers are people who build things for fun. But it's not just for fun. Raspberry Pi was founded by professors from the University of Cambridge. Back in, I suppose it was the 80s or 90s, there was a little board that was distributed out by the BBC to kids in the UK. And it was called I can't remember what it was called, Microbit or something like that. The new one is called the Microbit. But so they distributed these boards out for kids in the UK to play with, and every 7th grader got one. And they realized that the incoming engineering class into Cambridge, like however many years later, 5 years later, was spectacular. That if they gave kids these boards to tinker with, that they got really good engineering students. And then after this product kind of fizzled out, the quality went back down. And so the Raspberry Pi was built to get the quality back up. It was built to give kids a cheap computer that they could use to play with that would give us better engineers. It would give Cambridge better engineers, but it would give the world better engineers. And that's an incredibly powerful message and is still true, and lots of kids use Raspberry Pis to learn. And now the BBC Microbit is a little cheap board that's, again, being given to every 7th grader in the UK, which is mind-boggling. So, okay, makers are also people who use tools to build things to learn about electronics, to learn about software, to learn about how things are made. But then there's this third group. And this is kind of a new group, which is the types of people who launch Kickstarter campaigns, the types of people who look like me. And you see products geared towards makers, like Chip and Makey, for instance. But you also see all kinds of other products, like headphones. That are consumer products. These are built by people who would consider themselves makers. So makers are also people who use tools to build things for profit. But that doesn't really sound like a maker. That sounds like an engineer, right? And so the question is, what's the distinction? What separates makers from engineers? Are they, in fact, the same people? And if you do a Google image search, because I like to do Google image searches, and you search for maker, this is what you see. And look at kind of the patterns here, right? It's very colorful. It's very fun. It's definitely like there's some toy kind of stuff in there. And then if you do a Google image search for engineers, what you get is a bunch of mostly white dudes wearing hard hats, holding blueprints. So obviously the world thinks of makers and engineers as two very different things. And of course, this isn't really how we think of engineers. We think of engineers looking a little bit more like this, right? Like, you know, sitting in front of a screen with code. But regardless, that is not what the world thinks that makers are. But we had a theory. We had a theory that the reality looks something like this, that a lot of makers are engineers in the same way that engineers spend time coming to conferences, learning new technologies, playing with stuff at home, and then eventually that stuff finds its way to work, that this is true for makers too. And so we took a strategy that's very different from other companies, which is we went after makers in order to pursue professionals, in order to find people who wanted to go to scale, who wanted to understand how, who wanted our help and our software and our technology to help them support a product that goes to scale. And the result is that we found somewhat of a unique niche in this space, that most of the companies who target makers look for this overlap between fun and profit. Whereas we look for the overlap between fun and education. Whereas we kind of look for this overlap between fun and profit, which is a unique space for us to find. So what did we do? Well, we went pro. Instead of just making development kits, instead of focusing on making new and different development kits designed for anyone to be able to use, we started to professionalize. So we made the Photon, which uses the same chip that's in almost every consumer IoT product that you can buy. It's in Nest Protect, it's in LifeX, it's in Amazon Dash. It's the pro stuff, right? And then we decided to build a cellular product. And we did cellular because we had professional customers who were using our kits to prototype products like out on farms. And they're trying to get Wi-Fi networks out onto a farm, and we said, why are you not building this with a cellular connection? And they said, well, because cellular is too much of a pain and we don't want to deal with it. So we said, okay, great. Like, that's an opportunity for us to make that better. And then we started building some software. We already had some software, but we built software designed for people who are going to scale. So Clark mentioned products. Like, we're now providing tools for you to deploy firmware out to an entire fleet of devices. And that's a tool that professionals really want because they're building products at scale. And as a result, we've ended up being built into, there's 20 different Kickstarter campaigns for products that are built on our platform. And a lot of our customers are now starting to look like this. Like, we're supporting big companies for the products that they ship at scale. So the third lesson, and this seems a little bit, I'll explain this, is listen to your customers. And what I mean by that is, if we treated makers the way that everyone else treats makers, we would be in a very competitive business with lots of other people trying to, like, make tools for people to use for fun and education. And that's a great place to be, and it's a wonderful thing to do for the world. But there's lots of stuff there already. And what we heard from our customers is that they wanted something pro. They needed a tool they could really use to build an actual product. So we listened to that, and we took that lesson, and that became our business. And so we've now shipped 120,000 development kits. We have 70,000 customers. We've gone from 0 to 1 to 100,000. And it's been a fun journey. So that's it. Thanks for having me. If you have any questions, I'll be around. And I also want to make one quick plug, which is that if you're interested in this stuff, we're hiring. We have a distributed team. We're based in San Francisco. We have an office in Minneapolis and hire people around the world. So if you're interested, you don't have to know anything about hardware. Come talk to me afterwards. So thanks.